Okay, we've got a question about this sketch graph, which we're told is the graph of inverse sine of x. So this is one of the graphs you're supposed to memorize. So the way you're supposed to do this question is say, oh, I know this graph, and just whack on the coordinates. Okay, and that's what you should do. I'm not going to do that because just in case you're wondering why the graph looks like it is, okay, it is further earlier in your notes. But if we think about the graph of sine x, so this is y equals sine x, okay, this graph is related to this one, okay? It's not related to the whole graph. I haven't even drawn the whole graph because it goes on infinitely far either way. The graph of sine x, if you know that, is not one-to-one, okay? It doubles back on itself. So remember, you're not allowed to have two different inputs giving the same output. So at the moment, this angle here and an angle over here would have the same sign. So I've got to get rid of one of them. And the one I get rid of is all of these I get rid of because they give the same answers as these ones. And I get the same answers from these ones as from these ones. They have the same y coordinates. So I get rid of that bit of the graph as well. So we have just a section of the graph from here to here. And then, of course, we go from a function to its inverse function, and that's reflection in the line y equals x. Okay, you know that from earlier in the year. So now we have to reflect the coordinates. So what are the coordinates of this point? Well, we know that sine goes up to 1 and it achieves 1 at pi by 2, and it goes down to minus 1 at minus pi by 2. So when I interchange y and x, because I reflect in y equals x, then the x and y coordinates of these points flip round. So instead of having the point pi by 2, 1, this point is going to be the point 1 comma pi by 2. X and y change places. And equally, instead of minus pi by 2 minus 1, this is going to be minus 1 minus pi by 2. Okay, but you're supposed to know that. Okay, all right, and then on the same axes, I should say axes, sketch the graph of y equals minus the inverse sine of x minus 1. So this is transformations. What have I done? I've done a minus 1 inside, and I've done a times minus 1 outside. Okay, and we go through the order, okay, vertical first then horizontal, and vertically, what do? We stretch before we run around. Well, actually, the only vertical change I've got is this vertical stretch factor of minus 1. Now, the way we actually describe that, okay, it's a vertical stretch factor minus 1, which is a vertical flip. It's actually a reflection. And the reflection that changes things vertically is the reflection that hops to the other side of the x-axis. This is vertical motion when I go from one side of the x-axis to the other. So this is a reflection in the x-axis, okay, and then minusing 1 inside, okay, so it's going to be a horizontal change. It's going to be a translation because it's a subtraction. So it's a translation of, okay, and minus 1, because it's horizontal, is going to become plus 1. So it's a translation of 1 plus 1, 0. Because there's just one horizontal and one vertical, in fact, the order doesn't even matter. Okay, so if I reflect it, so I'll do it the normal way, so the vertical reflection first. So that would turn it upside down, so it would be coming like this. Okay, but then I've got to shift it 1 unit this way. Okay, so this, hang on, this is actually exactly 1 away horizontally from the y-axis. So P will have been reflected up here, and then it will go onto there. And then this curve's been turned upside down, so it's going to come down and then down, but starting from here, so it's going to come down. Okay, and I've done that properly because the intersection from the x-axis, this point here, will be unchanged by the reflection, but then it gets moved to 1. So that will be the point 1, which is the x-coordinate of Q, and then it will come down here. Okay, I've done that reasonably well. So I should really be polite and show these 3 coordinates here. Probably the 3 marks. So they're going to be marks probably for showing the coordinates. So this one is now the point. This has come all the way to 2. Okay, because Q has been reflected down. It already had a coordinate of 1, but it's been come across 1 this way, and it's going to be minus pi by 2 because it's now lined up with where P was, and this is going to be the point 0, obviously, pi by 2, and that bit of labelling, that should do. Good.